We're going to be dealing with section 6.1, adding and subtracting polynomials. First thing we're going to be doing is we're going to be talking about what is a polynomial. A monomial is a number or a product of numbers and variables with whole numbers and exponents. A polynomial is a monomial or a sum or difference of monomials. Each monomial is a polynomial, in a polynomial is a term. So for example, if I gave you something like 2x squared, this is a monomial. It's one term. It is the product of numbers and variables. So this is really times. Now if I give you like 3 plus 3x plus 5, this is a polynomial, but it has three terms now. It has one term here, one term here, one term here. What breaks up terms? Addition or subtraction signs. So anytime you see an addition or a subtraction sign, you know that that is breaking up a term. So here is a polynomial, 3x to the fourth, 2z to the 12th plus 9z to the third. It's a second, there's two terms in this polynomial. This one has one term, this one has one term, this one has two terms. Now these are not polynomials because it's raised to a power, a variable, not a number. And this is an absolute value, not a polynomial. If you have something in the denominator, a variable in the denominator, not a polynomial. Okay, and if you have a fraction for an exponent, not a polynomial. The degree of a monomial is the sum of the exponents of variables. Okay, so for example, if I had 2x to the third, y to the fourth, this monomial is to the seventh degree because we add up the exponents. So this is 3, this is 4, this is a seventh degree monomial. Okay. Identify the degree of each monomial. Okay, this is a 6th degree because we have 6 here. Oops, let me turn my marker on so I can see this a little bit better. Okay, so we have a 6th degree here, so this is 6. This is 0. There's no variable, so it doesn't have a degree at all. This x has a 1 here that we don't see, so this is a 4th degree. Here we have 2 plus 1 plus 3. So this is a 6th degree monomial. So in order to find the degree of a monomial, you just add up all the exponents on each on the term. A degree of a polynomial is given by the term with the greatest degree. So in this problem, the 3rd degree is the highest. So we call this a 3rd degree polynomial. In order to be in standard form, we always write it from highest degree to lowest degree. Now, this is when there's only one variable, like an x or a y. You can't have more, we don't usually write things in standard form if they're more than one variable, because how do you know which one to use? So if you had something like 3x squared y plus 5 y squared x minus z, we don't write this in standard form. But if it just has one variable, then what we do is we write it from highest degree to lowest, a 3rd, 2nd, 1st, and no variable. So this is standard form anytime you write it from highest degree to lowest degree. We classify polynomials in two different ways. Well, we just use the degrees. So if it's a 0 degree, it's a constant term. So for example, -9, that has no variable. We say it has a 0 degree. It is a constant. A linear function, the highest power is 1. Okay, so this is an example, x to the first. This is a linear function. A quadratic, the highest power is 2. A cubic, highest power is 3. Quartic, highest power is 4. Quintic, highest power is 5. So this is how we name polynomials, by using the degree the highest degree. Rewrite each polynomial in standard form. Identify the leading coefficient, degree, number of terms, name the polynomial. Okay, so here I'm going to rewrite this. This is going to be negative 5x squared plus 4x plus 3. This is a quadratic. The leading coefficient is -5. Highest power is 2. In this problem, I have 8x to the fourth plus 3x squared minus 4. So this is called standard form. highest term to the lowest term. All right, now, the majority of this week's assignment is just adding and subtracting polynomials. However, in order to add and subtract a polynomial, we have to know a little bit about terms and stuff like that. That's why I just reviewed all that stuff. Just as you can perform operations on numbers, you can perform operations on polynomials. To add or subtract polynomials, combine like terms. What is a like term? Like terms are terms with the same variable raised to the same power. So for example, if I had 2x squared plus 5x squared, this is the same variable to the same power. I can just add the numbers in front, and this would be 7x squared. When you add like terms, you do not change the variable or the power. Now, if I gave you 2x squared plus 3x to the third, these are not like terms. They have the same variable, but they are not to the same power. You cannot add those together. That is very, very important. You can only add like terms, and like terms have the same variable raised to the same power. To simplify expressions, combine like terms by adding the coefficients. Okay, coefficients are the numbers in front of the variables. Here are some examples. If I wanted you to add 12p to the third plus 11p squared plus 8p to the third, I find like terms. These are like terms. The 12p to the third and the 8p to the third, they have the same variable to the same power. So if I add that together, I end up with, whoops, what is that? 30p to the third. I cannot do anything with the 11p squared, so I just leave it alone. So my answer, oops, I'm sorry, that's 20. Don't know how to add today. 20p to the third plus 11p squared. Here, 5x squared plus 6 plus 3x plus 8. The only like terms are right here, the whole numbers. So I'm just going to leave this as 5x squared plus 3x plus 14. I always write my answers in standard form, highest power to lowest power. And I'd like you guys to do that also. So if I asked you on tonight's assessment to do this problem, you would say, okay, I'm looking at this. I've got 7m squared and 4m squared, so that's 11m squared. Those are like terms. I can add them together. The 3m I cannot, so I just leave it alone. Done. That's it. How about this one? Now, when you're dealing with addition, the parentheses really don't make any difference. I have 10pq, and I have 2pq. I also have a 6pq. I can add all those together. 10 and 2 and 6. That looks like 18pq. And then I have 3p and minus 5p, so that leaves me with minus 2p. So all that we're doing this week is we're adding and subtracting polynomial functions. You add and subtract like terms. If they're not like terms, you cannot add or subtract them. You just leave them. Now, the hardest type of problem, I think, is when you're dealing with subtraction here. There's really, and this is how I do these types of problems, there's really a 1 in front here. I always change subtraction to addition, change the sign directly behind. Here, I'm going to change this subtraction and make that -1. Here, I'm going to change that and make that. Now, this negative goes to all these terms. So my first parenthesis doesn't change. I have 14d squared plus -8 plus, and then -1 times 6d squared, that's -6d squared, plus -1 times -2d, that gives me +2d, plus -1 times 1 is -1. Okay, so now I've got the negative sign or the minus signs out of there. Now I can start adding like terms together. So I've got 14d and -6d. Well, that d squared, I'm sorry. That leaves me with 8d squared. Those are gone. I have -8 and -1. Well, that gives me -9, but I still have this 2d here, so I'm just going to add, because that way it's in standard form right away. And there's my answer. So this week, a very short week. We only have Monday, Tuesday, Wednesday. You guys have off on Thursday and Friday. And all we're doing is we're adding and subtracting polynomial functions. I hope to see you at the live main lesson on Monday from 10 to 11. Hope to see you all there. Bye.